उसका हवा Yes, anything to ask or shall we proceed?
Sir, are we having test tomorrow?
Yeah. Tomorrow we are having test.
Okay, sir.
Syllabus will be up to Gauss theorem only. Only 3 chapters.
Okay, sir.
Ray optics included, sir.
Yes?
Ray optics will be included.
No, only 3 chapters. These 3. Electrostatics one. Coulomb's
Okay,
law,
sir.
electric field intensity, and Gauss theorem. Only these 3.
What is the timing of the test, sir?
Yes?
What is the timing of the test from 3 to 7?
After 2 o'clock, it will be published, and up to 6 o'clock, I will tell him to remove it.
Sir,
Hmm.
sir, objective only will give us, sir. Don't give subjective, sir. Please, sir.
Okay, only objective is there.
Okay, thank you.
Yes. Shall we start
Sir,
now?
sir,
Yes?
total marks. Total marks.
Same 10 marks. 5 questions will be there, 10 marks. Each question of 2 marks. Like last time.
Okay, sir.
So we have done electric potential at any point due to point charge, and electric potential at any point due to many charges. If many charges are present, then how will you find electric potential at any point? Now today we shall discuss electric potential at any point on the axis as well as at any point on the perpendicular bisector of the dipole. Yeah, anyone having any confusion regarding the previous class? What we have done? Electric potential at any point due to point charge or many charges. Any doubt? No. Then we shall start this. Electric potential at any point first will be on the axis of dipole. That is end on position. So for that we will consider a dipole. Maybe this having plus Q charge, this is having minus Q charge, and this is the dipole axis. And at any point on this axis, we will consider this is point P. This length we are considering 2L or capital L. And from the center of this dipole, the distance between this is R. So this point is O. This point suppose A, this point is B. Okay. So this derivation is asked. either in 2 marks question or 3 marks question. So we will consider that two equal and opposite charges plus Q and minus Q is separated by distance 2L, or sometimes we say capital L, that is the length of the dipole. So let us consider So let us consider any point P on the dipole axis at a distance r from the center of the. Now we have to find the potential at point P. So first we will find what is the electric potential at P due to this plus Q charge. What is the electric potential at P due to this minus Q charge. So electric potential at P due to plus Q charge. So this will be 1 by 4 pi epsilon naught Q by R minus L and electric potential at P due to minus Q charge 1 by 4 pi epsilon naught minus Q over R plus L. So from B to P, R minus L, from A to P, R plus L.
So capital L or small L?
No, small L. When we are taking 2L, then small L. Capital L means suppose that length of the dipole is given 10 centimeter, then capital L is 10 centimeter. Or 2L is 10 centimeter, that means L is 5 centimeter. So this small l is the half of the distance or half of the length of the dipole. So in the formula, this L is half of the dipole length. So as it is scalar quantity, electric potential. So simply magnitude we have to consider, no direction here. So what will be the net potential at P due to electric dipole? So this potential plus this potential algebraic sum. So 1/4 epsilon naught Q over R minus L, and this one will become minus Q over R plus L. So this Q will take common. 1/4 epsilon naught or Q/4 epsilon naught. Q will be common. R minus L into R plus L will become LCM. Now, so this R will be cancelled. Plus L, and here minus of minus again, it will become plus L. So this one will become Q into 2L R squared minus L squared. Now this Q into 2L. What is that? Yes, Q into 2L.
One moment.
Dipole moment. So this V potential at point P, Vp will become dipole moment P, or if you are writing PE, no problem. That is electric dipole moment. 4 pi epsilon naught, or simply P you write like R square minus L square, where P, which is equal to Q into 2L, is electric dipole moment. So it is electric dipole moment, or simply dipole moment, as we are discussing electricity only, electrostatic only. So if you are not writing electric dipole, no problem. Dipole moment if you are writing. So Q into 2L is dipole moment of the dipole. Now, if this R is much more than L, sometimes length of the dipole will not be given. So in that case, we will assume the point P is far away from the dipole. So R is much more than L. Then what will be? This R square minus L square will be approximately R square. And this electric potential will become 4 pi epsilon naught r square. So this is valid only for large distance. And this is the general formula for any point. This is the general formula. If length of the dipole is not given, then we use this formula to calculate electric potential. Now, second is at any point on the perpendicular bisector of the dipole. So in this case, suppose this is the dipole, this is plus q, this is minus q. We are considering any point P on this perpendicular bisector. Okay. So this is here is the point from the center of the dipole. Now you find yourself what will be the electric potential at P. This first part, let us consider one will be same as, and similar steps will be there. So you find what will be the electric potential at point P due to this dipole. Yes, got?
Zero, sir.
Yeah, it will be 0. So what will be here? If this is distance r, this is L, then this distance S will become R square plus L square under root. So electric potential at P due to plus Q. So that will become 1 by 4 pi epsilon naught Q over S, and due to minus Q, one by 4 pi epsilon naught minus Q over S. So net potential will be dipole will become 0. So electric potential at any point on the perpendicular bisector is 0. So when electric potential is 0, that doesn't mean electric field is 0. We have calculated already electric field. What was that? Electric field intensity at any point on the perpendicular bisector was 1 by 4 pi epsilon naught P over R cube with negative sign minus P over R cube when R was much more than L, and it was opposite to the dipole moment. So electric field, if electric potential is 0, that doesn't mean electric field is also 0. And same thing reverse also. If electric field intensity at any point is 0, that doesn't mean electric potential is also 0. If electric field is 0, that means rate of change of potential is 0. So potential is constant. Right, we know this E is minus dV by dr. So if E is 0, that means dV by dr is 0, which says V is constant, or V is 0. Both are possible. If 0, electric potential is 0, then also electric intensity will be 0. But it is not in all the cases. If potential is constant, then electric field will be 0. And if V is 0, that doesn't mean electric field intensity is 0. Here V is 0, but that doesn't mean electric field intensity is 0. So both are wrong. If you are saying V is 0, that means E is 0. Wrong. If you are saying if E is 0, V is 0, that is also wrong. So if E is 0, V is either constant or it may be 0 also. But it will not always 0. Now, if you are interested to find that at any point one, just to learn the formula only for competitive exam, I think in CBSE also not there, or maybe if it is there. So electric field and potential at any point due to dipole at any point. So this is not in syllabus. So in that case, you will be given only one condition will be given there. R is much more than L. For that only it is. It is not valid for all the situations. So in that condition, suppose this is the point P, this distance is R, this angle is theta. So this angle will be given. So angle between this dipole moment and this area vector is theta. The electric field intensity at P will be 1 by 4 pi epsilon naught P over R cube. It will be, I think, 3 cos squared theta plus 1 under 2. What was the formula for electric field intensity at any point on the axis of dipole? What was the formula? Forgot. It was 1 by 4 pi epsilon naught twice P over R cube when R is much greater than L. So if theta is 0, what will come? 3 plus 1, square root, say 2, so 2P over R cube. And when theta is 90 degree at any point on the perpendicular bisector, 90 degree means this one will become 0, so square root of 1, that is 1 only. So P over R cube. This is the magnitude, direction you are knowing. So this is only magnitude we are considering. And this potential will be, potential at any point will become 1 by 4 pi epsilon naught E cos theta over R squared. So when this is valid only for this situation. Just now we have got when theta is 0 degree, what was that? Electric potential at any point on the axis. Just now we have calculated 1 by 4 pi epsilon naught P over R square. So just if you want, you can learn the formula only for solving the numerical or just. So this is electric field at any point. In that case, two things will be given, R will be given and theta will be given. This theta is angle between dipole moment and position vector. Suppose this is minus q this side, plus q this side, then this angle means plus q this side, minus q this side, then this angle is theta according to this. Now, potential energy of system of charge, electric potential energy. First, we will take two charge particle system or two charge system. If only two charges are there, then what will be the electric potential? Sorry, potential energy, not potential. Potential energy of that system. So suppose you are taking this one. One charge is plus Q1, maybe minus or whatever it is. Other charge is Q2, maybe plus, maybe this. Now, what will be the potential energy of this system? So, how will you calculate potential energy? What is potential energy? Amount of work done by external agent in bringing that particular charge from infinity to that particular point. So, first of all, we are bringing, suppose, so this will be, so this potential energy will be work done in bringing Q1 from infinity to A plus work done in bringing Q2 from infinity to B. Of course, it is work done by external agent only. Work done by external agent in bringing Q1 from infinity to A, and work done. So total, how much work we have to do? Now we consider one by one. Okay, we have brought this Q1 from infinity to this point A. What will be the work done? Do we have to do any work? Yes. So we have not to do any work because no electric field is present. Why will do work? Suppose here plus Q charge is present from before, and we are bringing any other charge plus Q charge, then we have to do work because this charge will be repelled by this one. Or if this is minus Q charge, we will gain some work. So work done by V will be negative. If it is positive here and we are bringing positive charge, the work done by us will be positive because we will have to overcome this force of repulsion. Now, when we are bringing this first charge, no other charge is present in this region. That means electric field from before is 0. So work done in bringing this first charge will become 0. Now, when we start bringing this second charge Q2, this charge has already arrived here. So, to bring this Q2, we will have to overcome this force of repulsion due to this. So, in that case, we will have to do some work. And how much work? Charge into potential at B due to this plus Q1. So this one will be Q2 into electric potential at B due to plus Q1. Whatever the distance between these two is, suppose this is R1, 2.
So once again, can you please explain?
So this is 1 by 4 pi epsilon naught Q1 Q2 over R1 2. This frequently we use potential energy of two charge particle system. frequently we use this formula. Now suppose we are taking 3 particle system. System having 3 charges. So suppose third charge is somewhere here. So what will be same? Work done in bringing Q1 from infinity to A, work done in bringing from Q2 from infinity to B, plus work done in bringing Q3 from infinity to C. So here Q1, Q2, we have to write the sign also. If we are bringing negative charge, naturally we will gain some energy because there will be force of attraction. So work done by us will be negative. So electric potential energy may be positive, may be negative. So what will be this work plus work done in bringing Q3 from infinity to C. Same way, when we have brought this first charge, no field was there. So work done in bringing first charge will be 0. Work done in bringing this Q2, when we have brought Q2, Q1 is already present here. So it will be Q2 into electric potential at B due to A. Now we are bringing this third charge. What will be?
Q3 into net electric potential, sir.
Q3 into
Net electric potential produced due
electric
to
potential at C due to
A and B.
A and B, that is Q1 and Q2 both. Because before this is already arrived. This is already arrived. You may assume, okay, we will bring first Q3, no problem. You bring first Q3, after that you bring Q2, last you bring Q1, result will be same. That doesn't mean we have to bring first Q1 only. Whatever way you can think, result will be same. So in this case, we will have to add some more work. So this is plus Q3 into electric potential at C due to Q1 and Q2. So first work done 0. This one already have got Q2 into 1 by 4 pi epsilon naught Q1 over R12. Now this one Q3 1 by 4 pi epsilon naught potential at C due to A, this one. So this distance we are saying R13. Potential at C due to this one R23. So it is 1 by 4 pi epsilon naught Q1 Q2 over R12 Q1 Q3 by R13 this into